All right, let's get right to it. We're comparing linear functions today. So starting with our first one, which of the three sea animals is the fastest and how do you know? So we start off with these words here. The bottlenose dolphin can travel 8.5 miles for every hour. So if we're going fastest, we're looking for a rate of change. Okay, so I'm going to find my slope. For the dolphin, that's going to be 8.5 divided by 0.5, which is 17 miles per hour. And now since we're in hours, I've got to be careful over here because the sea lion is in minutes. So I need to change minutes to hours, which means I'm going to take my 12 minutes and divide by the fact that there's 60 minutes in an hour. And so 12 is 0.2. 24 divided by 60 is 0.4. 36 divided by 60 is 0.6. 48 divided by 60 is 0.8. And 60 divided by 60 is 1. All right, so when I go to pick 2 points, say like this 0.410 and 0.615, when I go to find that slope, I'm going to use my decimals instead of my minutes. So here we have 15 minus 10 over 0.6 minus 0.4. So then we end up with 5 over 0.2, and 5 divided by 0.2 is 25 miles per hour. The orca whale, when I go to find its slope, I'm going to do rise over run. So I'm going to start at 0, and I'm going to go to this point. So I'm going up 69 and over 2 hours. So now we're going to do 69 divided by 2, which is 34.5 miles per hour. Which means, which of the three is the fastest? That would be the orca. And the reasoning is because it has a greater rate of change. All right, next example. An 8th grade class wants to hire a DJ for their end of year party. Write an equation that represents the total cost of Y for hiring each DJ for X hours. That's our first stop. So DJ A is $20 per hour. So that's our Q that we have in X, right? So $20 per hour plus a $75 setup fee. So plus 75. So that's my equation. Y equals 20X plus 75. DJ B. Here's my y-intercept, so my b is 0. I need to find my slope, so I'm going to pick 2 points. We'll do these two, a random 2 points. So we're going to do 120 minus 80 over 3 minus 2. 120 minus 80 is 40, and 3 minus 2 is 1. So our slope is 40. Our y-intercept is 0. So we have y equals 40x. Excuse me. All right. Now looking at this equation here, we need that m and b. So b is going to be 50. And m, we cross here. So we went up 25 and over 1. So m is going to be 25 over 1. Which is 25. And so that would be y equals 25x plus 50. From here, so those are my A's. B, which DJ charges the highest hourly rate? So this hourly rate, that's our slope. So here we have $20, here we have 40, and here we have 25. So the DJ that charges the highest rate is going to be DJ B. And that's happening at $40 per hour. Which equation shows a proportional relationship between the number of hours, X, and Y? And remember, we have to have a constant rate of change and it has to start at 0, 0. And the only one that does that is, again, DJB, because it has that 0, 0 starting point, whereas DJC started at 50 and DJA had that setup fee of 75, which is our slope intercept. If you only have $150 to spend, which DJ can you hire for the longest period of time? So what that means is this 150 is going to be our Y. And so I'm going to do 150 equals 20x plus 75. We're going to subtract 70. Now this takes us back to chapter 2, solving equations. We're going to subtract 75 from both sides. 150 minus 75. Oops. Is 75. So I'm just great. I should have known that. Here we are. 75 equals 20x. Divide both sides by 20. 75 divided by 20 is, x would be 3.75 hours. So less than 4 hours. If we put 150 in for y, so we'd have 150 equals 40x. So now we're going to divide by 40. So 150 divided by 40 is 3.75 hours. So those are the same. And then we have 150 equals 25x plus 50. So we subtract 50 from both sides. We end up with 100 equals 25x. Divide by 25. And we get that for DJC, x is 4 hours, which is the better option. So which DJ can you hire for the longest bit of time? And that would be DJC. And so that's how we take and we use a sentence, a table, and a graph to compare. All right. Next comparison. For each city, there's a linear function that describes the temperature in degrees Fahrenheit in terms of the number of hours since 8 a.m. Which function has the greatest rate of change, and what does that mean in this situation? So right now we've got Hilltown, Eastbury, and Topperville. We want to know the greatest rate of change, so that would be slope, right? So at Eastbury, at 8 a.m., the temperature was 62 degrees. And between 8 a.m. and noon, the temperature increased by 3 degrees per hour, and that per is our rate of change. So for Eastbury, that's 3 degrees Fahrenheit is our slope. For Topperville, our slope is next to our variable. Here's our variable term, which means for Topperville, our slope is 2 degrees Fahrenheit per hour. And then to figure it out over here, we're going to do some subtraction. We're going to do 64 minus 62 minus over 9 minus 9. It should be 9. Because this was hours since 8. So 9 a.m. would be 1 hour since 8, and 8 would be 0. So 1 minus 0. So 64 minus 62 is 2. 1 minus 0 is 1. So we end up with 2 degrees Fahrenheit. So which one has the greatest rate of change? Eastbury. And what does that mean? It means that its temperature is increasing faster. So answer Eastbury, and it means the city is getting, warmer faster than the others. All right, part 2 on this one. For each city, there is a linear function that describes the temperature. Compare the initial values of the temperature function. So the initial hours since 8 a.m. So here I need to go to 8 a.m. This is my initial for Hilltown. At 8 a.m. the temperature was 62 for Eastbury, and Topperville has the equation, so that's our constant is our temperature at 8 a.m. which was 54. So compare the initial values of the temperature functions for the three cities. Well, Eastbury and Hilton have the same temperature, and Topperville has a lower temperature. What does the initial values mean? These are the temperatures at 8 a.m. on a given day. That's what those temperatures are. And that is what we have for today. That is it. Until next time, 8th graders, keep being you.